So the title of my presentation was the DDB collection and the limits of artificial intelligence, so it's a bit clickbaity. While I was preparing my presentation, I realized this is not the best title for the content, so I changed it to the challenges of legacy metadata, which is what I am working on, or working with. So as Lars mentioned, I work for FIZ Karlsruhe as a junior researcher, and I'm also a PhD candidate under the supervision of Professor Harald Sack. And my project was funded by Neustart Kultur, and this will be the outline of my talk. The first item on the list is the goal of the project, which is to create a knowledge graph out of the metadata collection of the German Digital Library. Oh, by the way, who has never heard of the German Digital Library? Raise your hand. Okay, good. Oh, there's one, okay. Okay, it was launched in 2009 as Germany's aggregator to Europeana. But I will talk more about DDB in the second section, which I will show you the DDB pie, or the content of the DDB, and also some art in marzipan. And then I will talk about the current metadata models or ontology in the DDB, as well as the proposed ontology for our goal of creating a knowledge graph. And then the main bulk of this talk is actually our attempt in FRBR-izing metadata. And our results, and some explanation of our results, and lastly, conclusion. So I'll try to make it short, since I'm the last person keeping you away from lunch. Okay, so the DDB in a knowledge graph. So that's the goal of the project. So the DDB, as I mentioned, is the country aggregator to the Europeana. At the moment, we have close to 500 data providers from different memory institutions in Germany. So from libraries, museums, archives, research institutions, multimedia libraries, as well as institutions responsible for the preservation of cultural sites. And the project's goal was to restructure the DDB by orienting the restructuring to the users. So user-oriented restructuring of the DDB. So we would like to help users find what they are looking for, not just expert or domain experts, but practically general users or most users. So here you see an icon of the knowledge graph, and we would like to enable semantic search and exploratory search. So yes. So now let's look at the DDB pie. So this is not, I think today it's now 52 million objects. But I did this in August last month. So there are 60% of the DDB pie is composed of metadata representing archival descriptions or archival document descriptions. But these are mostly non-digitized. And the next largest contributors are from the libraries with 30%, or equivalent to 15.71 million objects. And of these, 12.67 million are digitized text. So this will be what my dataset is, the digitized, or the metadata representing the 12.67 million digitized texts. Okay, I promised art in marzipan. Okay, so current state of the DDB can be represented by this example search of Schiller's Räuber, or Friedrich Schiller's famous drama, The Robbers. There's a QR code there if you take a picture of that, it will show you the search results. On the first page, you will see a lot of pictures of performances of the rubbers. And then on the second page, you will see this. Friedrich Schiller reciting the rubbers. It's actually an imprint on marzipan. So, and on the fifth page, that's when we get to see the actual thing that we are looking for, which is the rubbers, the drama by Friedrich Schiller. So, so there are a lot of objects in the DDB. They're highly granular and also very varied. So from art in marzipan to books to manuscripts, audio, you name it, we have it in the DDB. Okay, so under the hood, the DDB collections metadata is represented using an extension of the Europeana data model. So the Europeana model combines two paradigms or modeling paradigms, object-centric and event-centric. So up here is the event-centric modeling paradigm, where we use an event to link the item to these contexts, time span, place, and the agent. And down here we use Dublin core and DC terms to relate the descriptions of the object. So DC subject here, type, creator, DC terms created, and the DC term subject. Okay, so all objects are instances of EDM provided CHO. So regardless of whether it's a picture of marzipan art or manuscript or page of a book, it's an EDM provided CHO. Okay, so we would like to have a data model, or we would like to adopt a data model or ontology that will enable us to distinguish between an art in marzipan photo and a book. And we would also like to be able to relate these items to each other. So we thought about this problem, and we came up with adapting existing domain-specific ontologies, as well as adapting an upper-level ontology, in this case, FRBR or FRBR-based ontologies. So I highlighted libraries here because I will just be talking about objects in the libraries. To the right is the QR code of the ontology that we adapted. There are classes, properties, data properties. You can scan it again. It's on GitHub. So our main goal now, since we decided to adapt FRBR as our upper ontology, is to be able to align our EDM provided CHO instances to the different conceptual levels of FRBR. So to the right, we also use Fabio because collection of DDB, we have not only contemporary objects, but also rare manuscripts where there would be no manifestation or expression, would just be work connecting directly to item. So I need a break. Sorry. Okay. So we know that most users actually seek works and expressions, and we also know that MARC records are conceptually aligned to the manifestation level, but we follow the prescription of the Europeana technical report, where we align the EDM provided CHO on the item level. So now our problem is how do we create the instances on the upper conceptual levels, which means work, expression, and manifestation. Most importantly, how do we do that? How do we create the instances on the work level? Okay, before I continue, I would like to set this record straight, that the objects in the DDB are highly hierarchical and very granular. So when I say one object, it's equivalent to one metadata record, but it doesn't mean that it's equivalent to one physical item. So it could be one physical item or part of a physical item. So here we distinguish between two types of objects. So primary object. So in this picture here, this refers to the book itself, which is the Trauerspiele von Friedrich Schiller, or the dramas of Friedrich Schiller. And secondary objects, and these are the parts of the book. So here, because it's a collection of Friedrich Schiller's work, we have the robbers and also the third act of this drama. So these are parts of the item. So note that secondary objects in this case is also or can be aligned to a work. So Die Räuber is definitely a work, but Dritter Aufzug is not a work. And I would also like to show you that one extension of the EDM is to define a property called hierarchy types, where they indicated the different types of objects, like is it a monography, or is it the section of the book, or is it Handschrift or manuscript. So these are the distribution of the different types of hierarchy types for primary objects. And for secondary objects, we have chapters, we have volume, and so on. So for our FRBR-ization attempt, we only considered what we call the content H type. So a notebook or a heft is definitely not, may not be a work, or highly likely not to be a work. So we excluded this from our reconciliation efforts. So yes, so now let's talk about the FRBR-ization. So we looked at these properties: title, agent, and event, or the time span. And we reconciled it against the GND, or the German Authority File list of works. And we have different matching criteria depending on the property. So for text, we use full text search, and for agent, because there is flexibility in values, like properties can be assigned literals or controlled vocabularies, and sometimes 36.64 of the time these agents are linked to GND or VF, so we have different matching criteria. Okay, so we might be wondering what our results were. So based on our heuristics alignment and excluding the non-content DDB hierarchy types, which means that we tried to match 5.6 million records versus 485,000 GND VAC, and this GND VAC list was from June 2022. We only were able to reconcile 1.32% of the DDB metadata that we have. And note that this reconciliation is many-to-many match, so it's not one GND to DDB, but many-to-many. So that's disappointing. And we looked closely at our data, and we find that not all of the data and object properties have assigned values. So for example, properties that we need to identify an item as a possible creative work, they are rarely present. So here we can see DC creator, DC publisher, and DC contributor down here. So 18%, 16, 13, 11, and so on, so very low. And subject terms are also being used sometimes to do work reconciliation. So here, 11.83% of the time, so yes. And looking at our reference data set, looking at the GND properties, it's the same story. So we have records without agents in the DDB 59.27% of the time, and in a GND 33.68% of the time. So we're excluding here the first composer because we're just looking at the monography. So question now is, why are pertinent information missing? Yes, big question. So let's look at the cataloging standards. So since our dataset is composed of metadata, and these metadata were based on catalogs, and we looked at the distribution of the objects that we have in terms of their inception year. So objects in the DDB, they span several millennia. And it was only until after the French Revolution that the cataloging standards were standardized. So this could explain why we have this missing information. And also that items from antiquities may not have any attribution in terms of author or date. So yes. So now the question, with all the language models, machine learning, AI, can we then compute similarity measures based on titles alone? Because almost 100% of the time we have titles in our metadata. Here's a book or a tome, I would say. I don't know what it is. I saw it in Wilshire Bibliothek, so I'm not sure. So non-contemporary metadata, they have very lengthy titles. So, and they also include extraneous information. Sometimes they have the author there, or part of the volume, and sometimes even abstracts. So we looked at the average token length of the top 5 languages found in titles. So for German, the length is 13.27 and so on. Then for Italian is 42.54. Of course, this is not correct because the language identifier for short text, they only have between 60 to 65% accuracy. So it confuses Latin and Italian. So I would say that the contribution to the title length are mainly Latin titles and not Italian titles. I'm running out of air and I have 5 minutes left. Okay, so semantic similarity on titles. So we used pre-trained language models, multilingual models, and sentence transformers, and also use FIZ for semantic similarity. And we can say that based on titles alone, it's not enough. So here we can see this is a positive, true positive, so 70% similarity score. The second one is a collection of Homer's hymns, Homerian hymns and epigrams. So this is a false positive. Another one is also a false positive because this is a parody of Homer's Iliad. And last one is a true positive, but very low similarity score. So, conclusion. Yes, we have significant challenges in the FRBR-ization attempt of legacy metadata, in particular aggregated metadata, because of the insufficient information, and also we have non-uniform metadata quality, and our external reference, which is the GND, also have incomplete information. And if we use only pre-trained language models to find matches based on titles alone, it's not that reliable. And for further work, we would need inputs from data providers and also from domain experts. So I would like to thank you for your attention, and I would like to take this opportunity to do some plugging. So we have Knowledge Graph online course hosted by OpenHPI, and it will start on October 11, and it will run for 6 weeks. And here we will show you semantic web technologies, some crash course on NLP, and also knowledge graph embeddings. So thank you.
Right, thank you very much, Marianne. I'm sure there are quite a lot of questions on this topic.
Yeah, thank you for the talk. It's quite interesting. I'm in particular interested in this machine learning based similarity models between the different items. So as far as I understood, you only used a pre-trained model in order to compute these similarity scores and did not adapt it to your data. Do you plan to do that, or did I misunderstood something?
Yes, you're right. You didn't misunderstand. It was off the shelf. We didn't fine tune it. If that's what you're asking, no, we didn't fine tune.
Right, because I think I mean in particular in the image similarity space there is approach that is called contrastive learning. So for training multimodal models for image to text similarity, but these approaches can also be adapted to text similarity, and it might be a useful approach for you to consider that.
It might be, but the digitized images for text like books, what DDB gets is already low resolution, and also these texts have the objects are not contemporary, so that the fonts typography. They vary, and also for manuscripts, for instance, they also have decorations. So, but it's a good idea. Maybe we could try it. Thank you.
Antoine?
Yeah, thank you for the presentation. I was wondering whether it raises also question for the GND works. Sorry for the authority person behind it. Have you actually checked where there's not a match, whether it actually is in the GND the GND works? Because I suppose that there are more than 500,000 German works, so it's probably a work in progress, and it could be that those things are just not yet in the GND.
That's possible. So out of the 480 something records for Welke, there are also a mixture of different types of work. So there's musical work and literature. So we only looked at the literary part and not the musical works. But it is also possible. So yeah.
I can contribute to that. Yes, a large part, I don't know, still in the majority of the works in the GND are actually musical works, because that's how the collective work started. It was really for the music cataloging, but we're working at it.
Yeah, but I also know that GND also has links to Wikidata. So for instance, there are around 14,000 GND work that have same as links to Wikidata. So we're also looking at that.
One question over here.
I was just going to say, if the GND is anything like the Library of Congress NACO authority file, for the most part, catalogers working with NACO don't create work authority records. We only create them in relatively rare situations, particularly when we have translations. When we need to specify an expression, we typically create an authority record for the expression, and we're not required in NACO to create an authority record for the work. So that explains in my mind, why, if it's similar with the GND, there's a lot of works that just never get authority records.
I'm also not privy to how the GND VALCA records were created or when and how, so. But thanks for that insight.
They are created intellectually, and they're also machine processing in the making to create work records from bibliographic data, sort of clustering the information to pull out a work record from that. But it's not operating yet. One final question before lunch? Blood sugar is low. Okay, so thank you very much, Marianne.
Thank you.
Thank you all for attending and listening and your questions.